Hi guys, what's up? I'm Dinesh. Welcome you all to our YouTube channel and welcome you again to the next lecture of the chapter Matrix and Determinant. As I have promised, this lecture is based on the properties of symmetric and skew symmetric matrix and one problem. Okay, so let's see the properties. What are the properties? If a square matrix, then A plus A transpose is symmetric. Okay, so before seeing the properties, just I want to remind you for symmetric matrix, your A transpose is equal to A, and for skew symmetric matrix, your A transpose is equal to minus A. This is important. So let's see each and every properties and prove these properties as well. Okay, if let A be a square matrix, then A plus A transpose is symmetric. So how can you prove? For symmetric of A plus A transpose, you just take its transpose. Okay, you have to follow this method always. Take its transpose. So apply the rule you have already seen in the rule of transpose of a matrix or properties of a transpose of a matrix. A plus A transpose is nothing but A transpose plus A transpose. You have already seen A transpose, you can write it A transpose plus transpose of a transpose matrix A, you will get A, which you can write simply as A plus A transpose. So what you start with transpose of A plus A transpose and you come back with A plus A transpose, which is simply of the form A transpose is equal to A. So if A is a square matrix, then A plus A transpose is symmetric. Verified. Okay. Similarly, if A be a square matrix, then A minus A transpose is skew symmetric. Okay. So to prove that, just take simply way A minus A transpose. Okay. Then see what you will get. This is nothing but A transpose minus A transpose. Okay. So you will get A transpose minus A. If you take one minus common, you will get A minus A transpose. Okay. So you just come back with A minus, you started with A minus A transpose, you will get with minus of A minus A transpose, which is similar to A transpose is equal to minus A. So you verified that if A is a square matrix, then A minus A transpose is skew symmetric. Let's move into the third properties. If A and B are symmetric matrices of same order, then AB is not symmetric. This is important to show you. For AV, to check AV is symmetric, you have to take just simply AV transpose. In properties, you already studied that AB transpose is equal to V transpose into A transpose. Okay, so given AV are symmetric, so A transpose simply equals to A and B transpose simply equals to B. So AV transpose you will get BA, where you already know AB is not equal to VA, so that AB is not symmetric whether A and B are symmetric. Okay. And the next properties is any power of symmetric matrix is symmetric. Any power of symmetric matrix is symmetric. What does it mean? If A is a symmetric matrix, then A to the power n is also symmetric. If A is symmetric, then is also symmetric. It said that if A is symmetric, then A to the power n is also symmetric. So how can you prove? Just take A to the power n transpose. You will get A to the power n is nothing but A into up to n times transpose. You will get from back to first, you will simply sum your A is equal. So you will get A transpose, A transpose, A transpose up to n times. So as A is symmetric, you will get A into A into A up to n times. So you simply come back with A to the power n. So A to the power n transpose is equal to A to the power n. So you can verify any power of a symmetric matrix is symmetric. And the next is odd power of skew symmetric matrix is skew symmetric. For a skew symmetric matrix, you know A transpose is equal to minus A. So it said odd power of skew symmetric matrix. Simply we take A to the power n transpose, you will get in the similar way you will get A into up to n times transpose. So you will come back with minus you will come back with A transpose up to n times, and you will come back with minus A up to n times. So which will give minus A to the power n, or you can say minus 1 to the power n into A to the power n. So in general way, if A is a skew symmetric matrix, then A to the power n can be written as minus 1 to the power n into A to the power n. For n is even, then you will get A n transpose is equal to A n. So which is a properties of symmetric but not skew symmetric. Okay, so even power of n is given you A is a symmetric matrix, or A to the power n is a symmetric matrix. For n is equal to odd number, you will get A to the power n transpose is equal to minus A to the power n, which is skew symmetric, properties of skew symmetric matrix. Okay, method to find skew symmetric matrix. Okay, so odd power of a skew symmetric matrix is skew symmetric. These are very important and useful properties of symmetric and skew symmetric matrix. I hope you understand better and read well to apply these concepts in important or critical problems. Okay, next I solve an example. The example given, find A, X, Y, Z which are constant such that matrix A is skew symmetric. A is skew symmetric. So here given A is skew symmetric, just apply one and one properties I have discussed already. Okay, not symmetric but skew symmetric. Okay, sorry. So if A is skew symmetric, what are the properties? What are the properties? The diagonal elements must be 0. First properties apply. Diagonal elements must 0. So here you can verify these are the diagonal elements. So all are equal, already given. So A equals to 0. First answer you get A equals to 0. Then you may go through A transpose is equal to minus A, find A transpose, then equal with this matrix, then you can get answer. But I am going through the element wise. You have already studied Aj equals to minus Aij. So here Aj, first if you check for A12, so A12 equals to minus A21 simply. So just take A12 is x plus y in any way equals to minus 4. Okay, and similarly you will get from this is the element number A31 equals to minus A13 obviously. So we will get x minus y equals to minus 3. So you'll get x plus y equals to minus 4, x minus y equals to minus 3. So from these two equations you can get 2x, you just add it, 2x equals to minus 7. So x equals to minus 7 by 2, and put the value of x here, you will get y equals to minus 4 plus 7 by 2, you will get minus 1 by 2, because this is minus 8 plus 7 by 2, this is minus 1 by 2. So you get x, y, and finally just equivalent, this element is nothing but your a 3 2 equals to minus a 2 3, obviously. So if you equal it, a 3 2 is your 2z equals to your minus y plus z. So if you open this, you will get 2z plus z equals to minus y, which is 3z equals to minus y, implies 3z equals to, we have already find out y, so this is plus half, implies z equals to 1 by 6. So these are your constants which you have to find out. Okay, so in this way you can solve any problems based on the concept symmetric and skew symmetric of a matrix. I hope you better understand. So if this video is helpful for you, please like the video, share the video with your friends, and never forget to subscribe the channel. Thank you so much for watching the video.